Dear students, today let us see the concept of integration. So, how can we define integration? It is called an antiderivative. It is the reverse process of differentiation. Reverse process in the sense, for example, let us take an example. If we take a function y is equals to f of x, if I differentiate this one, then I will get f dash x, and if I again integrate this one, then again I will get f of x. So a function on differentiation give f dash x, and on integration again it will give f of x. That is, here integration nullifies the effect of differentiation. That is how we can call integration. So therefore we can say integration removes or nullifies the effect of differentiation. So this is how we can define integration. So let us see integration in some more detail. We have two types of integration. One we can call it as definite integration. Second one is indefinite integration. Definite integration in the sense, this integration is carried within certain limits. So there will be certain limits of integration under which we will do this integration. There will be one upper limit and there will be one lower limit. Whereas if you take indefinite integration, there will be no such limits. So let us take an example of indefinite integration. For example, if we take y is equals to 6x plus 7, another function y is equals to 6x plus 8. Let us differentiate this function with respect to x. Then dy by dx is equals to 6. Here also if I differentiate, dy by dx is equals to 6. Now if I integrate this function again, then I should get the original function. So let us see. So this relation can be written as dy is equals to 6 dx. Here also I can write dy is equals to 6 dx. Now we apply integration on both sides. Integration, integration, integration and integration. So then this integration and differentiation, they are just opposite, so they just get cancelled. So I will write y is equals to integration 6 dx. Here also I will get y is equals to integration of 6 dx. So y is equals to integration of 6 dx is 6x. Here also y integration of 6 dx is 6x. So on integration again, we got these relations y is equals to 6x and also y is equals to 6x. But here we did not get any idea about the constants which are present. Here the constant present is 7, here the constant present is 8. So there is no idea on this constant. So therefore, always in the case of indefinite integration, we always indicate that unknown constant by a term called c plus c. So here also we write it as plus c. So always in the case of indefinite integration, after doing the integration, we write a constant called plus. So this point we go on writing the c values and all these integration concept now. So after this, let us see some of the formulae of integration. For example, formulae of integration. So all these formulae of integration can be obtained basically from the formula of differentiation itself, because integration is the reverse process of differentiation. So let us see some examples. First one, d by dx of x power n plus 1. So we know what is the result of this one. We can write it as n plus 1 into x power n plus 1 minus 1. So therefore n plus 1 into x power n. This is the result. So let us try to integrate this one and let us see what is the answer we will get. The same relation we can write it as d of x power n plus 1 is equals to n plus 1 into x power 1 x power n dx. This is how we can write. Now let us take this constant to this side. So d of x power n plus 1 divided by n plus 1 is equals to x power n dx. Now let us try to integrate on both sides. So we get this integration and differentiation gets cancelled. So then see what is the result we got. We got integration of x power n dx is equals to x power n plus 1 divided by n plus 1, and we have to place a constant, just we discussed now, and this is our answer. So integration of x power n dx is equals to x power n plus 1 divided by n plus 1 plus c. So that is our answer. So this is a very important formula in integration. Very carefully we should remember this formula. So let us see one more formula. So let us write d by dn of d by dx of ln n ln x. So this relation also we have discussed in the previous lectures. So this can be written as 1 by x. Differentiation of ln x is 1 by x. Now we are same, just we have written in the previous condition. Let us see how we can write this one. So d of ln x is equals to 1 by x dx. So therefore now if we apply integration on both sides, this and this gets cancelled. So ln x is equals to integration of 1 by x dx. So therefore integration of 1 by x dx is equals to ln x plus c. So this is our second result. So in this condition and this condition there is a small exception here. So integration of x power n dx, this can be applied for any power of n except n value is equals to minus 1. N value cannot be equal to minus 1 because this is that condition. So here integration of 1 by x can be written as x power minus 1 dx. So then what should be our answer? Integration of x power minus 1 dx should be equal to x power of minus 1 plus 1 divided by minus 1 plus 1. Minus 1 plus 1 is 0 and this is indefinite. So this is a wrong method of calculation. So this formula cannot be used for n is equals to 1. So n is equals to minus 1. So this we have to remember in this condition. Let us see one more relation. So d by dx of 1 by x, then this is equals to minus 1 by x square. So therefore how can I write in the same process? We can write it as d of 1 by x is equals to minus 1 by x square into dx. Therefore now if we apply the integration values, 1 by x is equals to integration of 1 by x minus 1 by x square into dx. Therefore integration of 1 by x square dx is equals to 1 by x plus. minus 1 by x plus c. So these three formulae we have written. Let us see some more formulae of this integration. So previously we have studied one more formula of this differentiation, that is formula number 4, d by dx of root x. This we have written 1 by 2 root x. Therefore, again let us do in the same method. D into root x is equals to 1 by 2 root x into dx. Apply integration limits and integrations. Then root x is equals to integration of 1 by 2 root x into dx. Therefore, we can write integration of 1 by root x is equals to 2 root x plus c. So this is one more formula which we can write. So when we observe here, all these formulae of integration are basically derived from the formula of differentiation itself. That is what I am trying to explain in this lecture. Similarly, let us see one more formula. D by dx of e power x is equals to e power x. Therefore, we can write integration of e power x is equals to e power x plus c. Same formula doesn't change in this condition. Let us see one more relation. So, d by dx of ln x can be written as d by dx of a power x can be written as a power x ln a. Therefore, again if we do in the same method, d of a power x is equals to a power x ln a into dx. Therefore, if I apply this integration values, a power x by ln a is a constant, so we can take it to this side. So this is equals to integration of a power x dx. Therefore, we can write integration of a power x dx is equals to a power x by ln a plus c. So these are some of the formulae we have in integration. Similarly, we have some more formulae in trigonometry also, trigonometric ratios. Let us see those relations also. So, formulae of trigonometric ratios. First one we have d by dx of sin x is equals to cos x. Therefore, integration of cos x dx can be written as sin x plus c. Second one, d by dx of cos x is equals to minus sin x. Therefore, integration of sin x dx can be written as minus cos x plus c. These relations, if you observe, are just getting the reverse results of differentiation. Let us see the third one, d by dx of tan x is equals to secant square x. Therefore, integration of secant square x dx is equals to tan x plus c. Fourth one, d by dx of cosecant x is equals to minus cosecant x cot x. Therefore, integration of cosecant x cot x is equals to cot x dx. That is, we are integrating with respect to dx here. So this is equals to minus cosecant x plus c. Fifth one, d by dx of secant x is equals to secant x tan x. Therefore, integration of secant x tan x dx is equals to secant x plus c. Similarly, we have one more relation, d by dx of cot x is equals to minus cosecant square x. Therefore, integration of cosecant square x is equals to minus cot x plus c. So, these are the formulae for integration of trigonometric ratios. Let us see some standard rules which we have in integration. So these rules are very important in applying the integration rules. Let us see. So we call them as rules of integration. First one, integration of k f of x dx, where k is a constant. Then we take this k outside. So this can be written as k into integration of f of x dx. Second one, so integration of f of x plus g of x dx. So in this condition, if we have two functions, then how can I write? I can write integration of f of x dx plus integration of g of x dx. This we know. Similarly, let us see one more very important rule of integration. Third one, integration of ax plus b whole power n dx. This can be written as ax plus b whole power n plus 1 divided by n plus 1 into 1 by a. Sima, in this condition, this ax plus b is a linear function. Linear function in the sense, here we have x power plus 1. So therefore, in this type of linear functions, we write this relation ax plus b whole power n plus 1 divided by n plus 1 into 1 by the coefficient of x which is present here. This we are supposed to write in this condition. So these are the three rules of integration which we are studying up to here. So if we just study some of the examples of this third relation, let us see. So we can write example integration of 3x plus 7 whole power 6 dx. So this can be written as 3x plus 7 whole power 6 plus 1 divided by 6 plus 1 into 1 by a. What is a here? A is the coefficient of x which is called as 3 plus c. So therefore 3x plus 7 into 7 divided by 7 3s are 21 plus c. This is our answer. So let us see some more examples of this one. For example, if we write integration of 9 minus 3x power 6 dx, then how can I integrate this one according to the third formula? So this here also same condition, 9 minus 3x power 6 plus 1 divided by 6 plus 1 into 1 by the coefficient of x. Here the coefficient of x is minus 3, so we write minus 3 plus c, and this is the result of our answer. So further you can simplify this one. So minus 3 into 7 minus 21, so you can write like this. So let us see one more example. So integration of 1 by 2x minus 3 whole power 4 plus 1 by 2 minus 3 by 7x whole power 6 dx. Then how can I write this condition? Let us see. So this can be written as integration of 2x minus 3 whole power minus 4 plus 2 minus 3 by 7x power minus 6 dx. Now after converting into this form, again we apply the same method of integration according to the same formula. So let us see. So this we can write integration of, no need of any integration now, directly we write the answer now. So is equals to 2x minus 3 whole power minus 4 plus 1 divided by minus 4 plus 1 into 1 by, the coefficient of x in this condition is 2. So 2 plus, now let us see the second one. So 2 minus 3 by 7x power minus 6 plus 1 divided by minus 6 plus 1 into 1 by, here the coefficient of x is minus 3 by 7. So minus 3 by 7 plus c, this is our answer. So you can further simplify this one. I am leaving up to here. So these are certain rules of integration. Now based on these rules and the formulae of trigonometric ratios, let us try to solve from some problems now. For example, first one, example integration of sine square x dx. Let us see how we can solve this one. So there is no direct formula of sine square x dx. We don't have any such formula. So let us see how we can convert to this one. According to trigonometric relations, we know that sine square x is equals to 1 minus cos 2x divided by 2. Therefore, same result we write here. So 1 minus cos 2x by 2 into dx. So 2 can be taken out of this integration. So 1 minus cos 2x dx. Therefore, half into, we can, so here there are two terms which are present. So we can apply integration to each of this term. So half into integration of 1 dx minus integration of cos 2x dx. So half into integration of 1 dx, we know it is equals to x, minus integration of cos 2x is sin 2x divided by 2 plus c. This is our answer. So let us see one more problem on this type of trigonometric relations. For example, if a question is given integration of cos square x dx, then let us see how we can do this one. So in the case of trigonometric relations, again we have relation cos square x is equals to 1 plus cos 2x divided by 2. So just substitute this relation here. So 1 plus cos 2x divided by 2 into dx. Again we can take 2 out of this integration. So half into integration of 1 by 2 dx, 2 already we have taken out, 1 dx plus integration of cos 2x dx. So therefore again we will get half of integration of 1 dx is x plus integration of cos 2x is sine 2x by 2 plus c. This is our answer. So further we can simplify this one, that you can do. Let us see one more example. For example, integration is given like this: integration of tan square x dx. So in this condition also we don't have any direct formula of doing this relation. So how we can do? We have relation secant square x minus tan square x is equals to 1. Therefore, secant square x minus 1 is equals to tan square x. So let us try to substitute this relation here. So integration of secant square x minus 1 dx. So we can separate this one as integration of secant square x dx minus integration of 1 dx. So we know integration of secant square x is tan x. So tan x minus x plus c. So this is our answer. So let us see one more example of this one. So for example, a relation is given like this: integration of cot square x dx. So again, just in the previous model how we have solved, we can do this relation. So we know cosecant square x minus cot square x is equals to 1. Therefore, cosecant square x minus 1 is equals to cot square x. So therefore, if I substitute this relation, so integration of cosecant square x minus 1 into dx. So again you can take this differentiation to both of these terms. So cosecant square x dx minus integration of 1 dx. So integration of cosecant square x is minus cot x. So therefore it can be written as minus cot x minus x plus c. So this is the answer to our relation. So let us see if we can do some more examples. For example, let us integration of sine power 4x dx. So here also there is no direct integration formula here. So this sine power 4x can be written as sine square x whole square. Therefore integration of sine square x whole square into dx. Now sine square x can be written as 1 minus cos 2x divided by 2. Therefore integration of sine square x whole square can be written as 1 minus cos 2x by 2 whole square into dx. Now this 1 by 2 we can take out of this integration. 1 by 2 whole square is 1 by 4. Integration of 1 minus cos 2x whole square into dx. Now this is in the form of a minus b whole square. Therefore if we expand this relation, 1 by 4 into integration of a square minus 2ab plus b square cos square 2x into dx. So we have expanded this relation according to a minus b whole square here. So cos square x can be written as 1 plus cos 2x by 2. But here the given relation is the term which is present is cos square 2x. So this cos square 2x can also be written as 1 plus cos 4x divided by 2. Therefore, we write 1 by 4 integration of 1 square minus 2 cos 2x plus cos square 2x can be written as 1 plus cos of 4x by 2 into dx. Therefore, if I apply the rules of integration now, so integration of 1 dx will be x minus 2 into integration of cos 2x is sin 2x by 2. So sin 2x divided by 2 plus integration of 1 by 2 dx is 1 by 2 into x, and integration of cos 4x by 2 is equals to half into sin 4x divided by 4 plus c. So this is our answer to this problem. Now you can further simplify this one and you can get the answer. So this is how we can apply the rules of integration and the formulae of trigonometric ratios and solve the problems. Let us see one more example of this one. For example, the integration is given like this: integration of 1 by 1 minus cos 2x into dx. So this is of the form, let us see, sin square x is equals to 1 minus cos 2x divided by 2. Therefore, 1 minus cos 2x is equals to 2 sin square x. So let us substitute this one here. So integration of 1 by 1 minus cos 2x is equals to 2 sin square x. So 2 sin square x into dx. Now 2 I will take out. So integration of 1 by sin square x into dx. So 1 by sin theta can be written as cosecant theta. Therefore, this relation can be written as 1 by 2 into integration of cosecant square x into dx. Now we know there is a direct formula of integration of cosecant square into dx, which is called minus cot x. Therefore, we can write half into minus cot x plus c. That is the answer to this problem. Okay. So let us see one more example of this one. So let us suppose this is the given question: integration of square root of 1 plus sin x dx. So let us see how we can solve this problem. Solving problems can be obtained by experience. If you solve more number of problems, then the brain becomes more and more sharper. We get the proper ideas of solving the problem. So let us see how we can solve this problem. So 1 can be written as sin square x plus cos square x. Same 1 can be written as sin square 2x plus cos square 2x. Same 1 can be written as sin square x by 2 plus cos square x by 2 also. And sin 2x can be written as 2 sin x cos x, and sin x can be written as 2 sin x by 2 cos x by 2 also. Now if you see this relation and this relation, then we can say definitely this equation is in the form of sin theta plus cos theta whole square. Therefore, how can I write this relation? We can write integration of, instead of 1 I can write sin square x by 2 plus cos square x by 2, and instead of sin x I can write 2 sin x by 2 cos x by 2 into dx. Now definitely I can say this is in the form of sin a plus cos b whole square, sin a plus sin b whole square, cos b whole square. Therefore, integration of, how can I write this one? Square root of sin x by 2 plus cos x by 2 whole square into dx. So this square and this 2 gets root gets cancelled. So therefore, integration of sin x by 2 plus cos x by 2 into dx. So now we have direct integration rules for this given functions. So we can write integration of sin x by 2 is minus cos x by 2 divided by 1 by 2, and integration of cos x by 2 is sin x by 2 divided by 1 by 2 plus c. So this is the answer to our problems.